Hello everybody and welcome. In this video we are going to convert a real denary number to the floating point representation using an exponent and Mantissa. This video does not cover the theoretical background. In this video we're just going to walk through the 4 simple steps we need to do to achieve this. If you're interested in the background information about why this works, you need to do some further research by yourself. Okay, we're also going to do it reverse. Let's say we start with a Mantissa and an exponent pair, and we're going to convert it back into a denary number. Let's start. There's basically 4 steps, and you need to memorize these 4 steps. First one, we are going to convert this number into binary. Ignore the negative for now. The second step is to convert to 2's complement form. The third step is to normalize. If you don't know what that is, that's okay. We're going to explain it when I get to it. And the fourth step is to calculate the exponent. The exponent depends on the number of positions we needed to shift the decimal point in the previous step. So we normalize by shifting a decimal point and count how many times we shifted it. This count value will be converted to a binary number in 2's complement form. Let's do it for question A. We have negative 7.625. Let's ignore the negative for now. 7.625. We've got the integer part, which is 7. Let's convert that to binary. So you will remember from last year that to convert 7 to binary, we just start with 7 and then we divide it by 2 and we get remainder 1. Then we move this down here. 3 divided by 2 is equal to 1, remainder 1. And then we move this 1 down here. 1 divided by 2 is equal to 0, remainder 1. So starting at the bottom and moving up, we just list these remainders. 1, 1, 1. Point. And now for the real part. Let's calculate the real part. We've got 0.625 multiplied by 2 equals, so in this case for the real part, or the part behind the decimal point, we don't divide but we multiply. 1.25, right? So next we take this 1 away, we ignore this 1 and we just are left with 0.25 and multiply by 2, and that's equal to 0.5. Then we ignore this 0 and we end up with 0.5 multiplied by 2 equals 1.0. Right? So we end up, we start at the top and we go down. So here we started at the bottom and we went up, and now we're going to start at the top and we go down. And that means it's 101. So now we're done with part A, but before we continue, let's check. I'm going to check it in a different number, in a different color, excuse me. So in order to check, we start at this ones position and we'd write a 1 over there. And then to the left we keep doubling and to the right we keep halving. So we got 2 over here and we got 4 over here. And then half, 1/4, 1/8. We end up with 4 plus 2 plus 1 plus 0.5 plus 0.125 equals, that adds up to 7.625. Right, so this we have so far correct. Okay, next step. That was all step 1. Step 2. Convert to 2's complement form. So remember from last year, if we want to convert a number to 2's complement form, we start by putting a 0 in front. So we have now 0, 1, 1, 1, 1, 0, 1. Now if this number was positive, we'd be done. That's enough for converting a positive numbers to 2's complement form. However, it's a negative number, so we have to flip each of the bits and then add 1 to the least significant bit. So that's what we're going to do. Flip the bits 1, 0, 0, 0, 0, 1, 0. This is called the ones complement. And to take the 2's complement, we just add 1 to the least significant bit. In other words, the one which is the furthest to the right. 1, 0, 0, 0, 0.011. Okay, now we need to normalize. So what does that mean to normalize? We need to shift this dot up in a way, either to the left or the right, in a way that it always starts with, if it's negative a number, it always has to start with 1.0. And if it's a positive number, it always has to start with 0.1. And in this case, it's a negative number, so we've got to shift up our thing 1, 2, 3 times. So we got E is equal to 3. If we shift it to the left, it's positive 3. If we shift it to the right, which can happen if we start with a whole bunch of zeros, or if we start with a whole bunch of ones, we're going to shift our decimal point to the right. In this case, we're shifting to the left, so it's positive 3. So we end up with 1.000011. How many bits is that? So we actually found our mantissa. M is equal to 1, 0, 0, 0. For the mantissa, we ignore this dot because it's standardized like this. 0, 1, 1. 1, 2, 3, 4, 5, 6, 7. And we have 8 bits for the mantissa. It says 8. And finally, step 4, we calculate the exponent. In this case, the exponent is positive 3. And we need to put that in 2's complement form. So to put that in 2's complement form, we just first convert it to binary number, which is 1, 1. And in order to put it into 2's complement form, because it's positive, all we have to do is prepend it with zeros. And we have 4 bits for the exponent, so we have e equals 0, 0, 1, 1. And that's all. Okay, let's do question B now. We've got negative 0.125. Okay, so start with step 1. Convert to binary. Ignore the negative for now. So convert to binary is easy. The integer part is easy. The integer part is simply 0, right? And now for the part behind the decimal point, we've got 0.125 multiplied by 2 equals 0.25. And then we've got 0.25 multiplied by 2 equals 0.5. And then we've got 0.5 multiplied by 2 equals 1.0. And then we're done. So remember, we start at the top and go down to the bottom. This is step 1, by the way. So we end up with 0.001. Let's check to see if we're right so far. Remember, we start above the ones. To the left we multiply by 2, but there's no point now. And to the right we keep halving it. So we end up with simply 1 over 8, which is equal to 0.125, which means we're right so far. Okay, step 2. Convert the 2's to 2's complement form. So remember, if it's positive, all we have to do is prepend with a 0. But we've already starting with a 0, so we don't need to do that. We can skip that step. However, it's negative, so what we have to do is prepend with a 0, which we can also skip. Then flip the bits, and then add 1 to the least significant bit. So let's do that. 0.001. Flip the bits. 1.110. Add 1 to the least significant bit. 1.111. Let's be very concise and start and check this as well. It seems like it's worth checking. So we do exactly the same as we did before, now that it's in 2's complement, except the front bit should be negative. So we've got negative 1 over here. Half, 1 over 4, 1 over 8. Let's add them up. Negative 1 plus 0.5 plus 0.25 plus 0.125 equals negative 1 plus 0.75 plus 0.125 equals negative 1 plus 0.875 equals negative 0.125. Is correct so far. Okay, the next step is to normalize. So remember when I said positive numbers always have to start with 0.1 and negative numbers always have to start with 1.0. Let's have a look. If I shifted this decimal point to the left, I would end up starting with 0.1, and it's a negative number, so it should not be like that. That's the wrong thing to do. The only other option I have is shift it to the right. So right now it starts with 1.1. That's not right. Shift it to the right. 1.1. Shift it to the right again. 1, 2. Shift it to the right 3 times. We end up with 1.0. Yeah? We are allowed to discard these ones. If you start with multiple ones, 1, 1, 1 in a row, multiple ones in a row, you can discard all of them. So in the end, we end up with 1.0 as our answer, with E equal to -3. E is equal to -3 because we shifted it to the right. So now we've got to convert -3 to 2's complement form. -3 in binary is -1, 1, right? So prepend with zeros. We've got 4 digits, so we'll prepend with 2 zeros. And then we flip the bits. And then we add 1 to the least significant bit. And now let's check. -8 plus 4 plus 2 plus 1 equals to -8 plus 6. Oh, excuse me, this 2 should not be here. -8 plus 5 equals -3. Correct. So final answer, M equals 1, 0, 1, 2, 3, 4, 5, 6. E equals 1, 1, 0, 1. Next question is question C. Convert the following Mantissa exponent pair to denary. So in order to do it backwards, you could do these steps backwards, but it would be much faster to just do it in the following way. First thing we do is we calculate E. So let's remove these steps. And then that's step 1, step 2, and then write M including the decimal point. And then convert M to denary. So in this case, let's start by calculating E. We've got 0, 1, 0, 0. Start 1, 2, 4. Remember, E is in 2's complement form, so we've got -8 as the first thing. E is 4 in this case. Next, that was 1. Step 2, write M including the decimal point. So we start with 1.011. 1, 0, 0, 0, and we shift up the decimal point 4 to the right, because E is positive. When we're undoing the effect of E, we're shifting to the right. 1, 2, 3, 4. We end up with 1, 0, 1, 1, 1.000. And now when we want to convert this to denary, we would just start up here 1.5 to the left, to the right, and double -16. We end up with -16 plus 4 plus 2 plus 1 equals -16 plus 7 equals -9. And there we have it. I hope this video was helpful for you. Remember, it's very important to practice these by yourself. If you want to give yourself extra exercises and you want to check yourself, remember you can always search for Mantissa Exponent Calculator, and for example, you can use this website to check yourself. Okay, good luck on your exams. See you in the next one. Bye for now.